start our first lesson, what I'd like to do is to go into a few what I call housekeeping details as to how I think we should set up our notebook and how we're going to proceed day by day. And let's talk about that for a few minutes right now, okay? Now, you have your textbook, and I'll say a little bit more about that later on. And also, I hope that you all have one of these spiral-bound notebooks, all right? And suppose you were to open that notebook to a page, any typical page, which might look like this. And what I'd like you to do is to get into the habit of putting the assignment, say, up on the left-hand corner, and then also the date on which you did that assignment, the date on which it is due in the right-hand corner. As the year progresses, I think that you're going to find this to be very useful to you, okay? And then as you do your problems, why don't you do, perhaps the first 2 or 3 problems, 1, 3, 5, and do them in a vertical fashion like this, and then go back to the back of the answers, the back of the book where the answers to the even-numbered problems in this book are, and actually check those problems, all right? And put a check mark here to indicate that you got these problems right, and continue then doing the problems without now referring back to the answers, okay? And continue doing the rest of your exercises in this fashion. And if you work vertically and then somewhere up here, then you'll start doing the other set of problems all the way down to whatever the last problem of the assignment is, okay? And then finally at the end, what are you going to do but to go back to the answers and check, okay? And again now this time, actually go through them all, and suppose there was some problem, one of these problems that you got wrong, all right? And so put an X mark there. I think if you leave enough space in your problems as you're doing them, wherever you got any problem wrong, I think you'll still have some room in there to work on it again and see if you can't get it right, okay? Then finally, at the end of your assignment, suppose there were 2 problems here that you got wrong, and 1 through 29, the odd, has how many problems in there? That would be a total of, 15 problems. Up at the top of your assignment, why then don't you write 13 over 15 and encircle it to indicate that you got 13 out of 15 of those problems correct, okay? And then occasionally I'll collect your notebook, and I'm going to go through it in this fashion, and just to see how you're doing with your homework, all right? Now, I assume that you do your homework on a daily basis, almost in a religious fashion, and you do it day in and day out, all right? And each day when you come into class, we'll go over those homework problems and make sure that everything is meaningful and correct to you. Now, the second time around, if you ever have any question about any problem there, please, that's when you want to ask about it and bring it up in class so that we can go over it and make sure that everything is perfectly clear, okay? And then I know that you understand, and we can move on from there. All right? Now, I think, certainly at the beginning of our work here, the assignments probably won't take you too long. I'm thinking in terms of half an hour, 30 minutes, 35 minutes by the time you read the material, study it, and do the exercises. And that's a little bit on the short side. And I think as the year progresses, I would expect you to be spending 40 minutes to 60 minutes on your homework assignment. And some people might be quicker than others and can finish it in 5 minutes flat. And perhaps there might be 1 or 2 people who will require more time than that. But overall, I think it should take you anywhere around 45 minutes, I think might be a nice round figure to use. Okay? Are there any questions about any of these housekeeping details? Let's then look at our book, shall we? And notice that the name of our book is Modern School Mathematics, Algebra and Trigonometry 2. And this is going to be a course in second-year algebra, which is going to lead very nicely into trigonometry as we just progress through the book. There are, I think, 3 chapters in the book near the back that refer specifically to trigonometry. And notice that there are 4 authors whose names are on this book, and that the publishing house is Houghton Mifflin Company, and whose headquarters are in Boston. And there are also 2 editorial advisors who have helped the authors in this book. Why don't you then open it to, let's say the front inside cover sheet there, the cover page. And notice on the left-hand side there's a pretty picture, and there's a description of that on the previous page. I don't think that you do this frequently enough. Every time you pick up a new book, I think it's a good idea to just go through it. People have spent a lot of time and thought and effort to put the book together right from the front cover to the back, and I think it's worth your while to see what is actually in there. On the next page, which would be Roman 3, I guess, or 4, there's a little description about the authors, a biographical sketch of the authors of this book and the editorial advisors. And then on page 5, notice that there begins the table of contents. And the book is set up in such a way so that for each chapter there is a chapter heading, and then within the chapter itself there are subheadings there in red, and then within each subheading there are paragraph headings or section headings there, numbered 1-1, and then there's a sentence, and then 1-2 in a sentence which describes what's going on in there. And each day, as we progress through this book and do our lessons, the caption and our credit will indeed be the wording that is given here. The numbering scheme, I think, is quite obvious. 1-1 refers to section 1 of chapter 1. 1-2 is section 2 of chapter 1, and all the way through the book in this fashion. All right? And if we are lucky and if we work hard, I think we're going to finish most of this book this year. All right? Let's then continue turning over here to page Roman 10. And notice there are credits for the various pictures that are in the book that the authors must include here to give credit from whomever they got those pictures. And then on page 11, there is a list of symbols that are used throughout this text. And if you look down there, perhaps the first dozen or so are familiar to you, perhaps more than that, but there might be some symbols in there that are not familiar. And as the year progresses, again, I think you'll know almost all of those symbols. On the next page, finally, then, is the beginning chapter of the book. And usually on the left-hand page, there is a picture which perhaps applies more or less to that chapter. And I think you might enjoy reading about some of that. At the top of each chapter, there's always a little bit of a heading, an introduction to give you some idea what that chapter is all about, and then the authors go right into the material itself. Okay? And this is how I think the book is set up. At the end of each chapter, there are some review exercises and other things which we'll talk about when we get to that. Well, let's then start talking a little bit about the first idea. And notice that the name of this lesson has to do with mathematical statements. All right? Mathematical statements. And before we start talking about statements, suppose I were to simply take some 2 plus 3, in which we have here what we might think of as, a mathematical, or simply we are dealing with numbers here, and I've taken two numbers and have combined them in some way. And we might think of this as a numerical, and what may we call it? Some kind of, Michael, a phrase, a numerical phrase, or maybe a numerical, the phrase, the word that the book uses, is a numerical expression. All right, a numerical phrase or expression is what we have listed here. Or perhaps another one might be something such as 17 minus 2. And, of course, associated with 2 plus 3, with that numerical phrase or expression, is a number. Is that right? This is a name for some number. And the way in which we usually describe that is to say that this is equal to this number, 5 in this case, and this is equal to some number. In this case, it's the number 15. And we call this the value of that expression, okay? The number here is the value for this expression in each case. And of course, the symbol that we have used here is one which we are familiar with. It names the same number here, and we refer to this as what? Well, let me just write, is equal to. Now, of course, all of this is old hat, very elementary stuff. I think you've seen this in probably the 6th grade or maybe even before that. But I think it's worth our while to review some of this material. Once we have some numerical expressions, you can then build up others from that. Suppose you had 2 plus 3, say times 4. Let me use a little dot symbol to indicate multiplication, in which we have some parentheses here to indicate additional operations. Or perhaps we might have 17 minus 2 times 3, all divided by, say, let me use this division symbol here, divided by 5. And we have here some brackets to to indicate our operations that we're going to perform. And there's a name that we give these symbols, and the authors use the phrase grouping symbols. All right? Here we have some grouping symbols to indicate various operations which we may perform on expressions. Okay? By the way, I may write this expression times 3 all divided by 5 in this fashion, in which this line here is also a grouping symbol that perhaps one doesn't think of it quite in that context, but it still may be thought of as a grouping symbol. Okay? Well, very quickly then, I think what we can do is to look at one of these sentences. Oh, again, a very simple little sentence. Now, can we decide whether this is true or false? Here's an assertion which I am making, and it certainly is a meaningful assertion that we have here. And the question is this true or false? And I think we will all agree that we may answer that question. In this case, we know that this statement here is true. Suppose I were to write, say, 17 minus 2 is not equal to 15. And what now is our conclusion about this? We may say that this is false. And when we have a meaningful statement or a meaningful assertion which we can decide whether it is true or false, we give that a special name which we call a statement, okay? In which we have some statements here. So for our discussion then, a statement is a meaningful sentence or an assertion which we can decide definitely as to whether or not it is true or false, okay? And in fact, we might even call these simple statements, because very quickly, what you can do is to take one of these statements. Oh, let's take, say again, 2 plus 3 is equal to 5. And let's take the other statement that I just wrote down, 17 minus 2 is not equal to 15. Okay? And we may combine these two statements by use of some words that we have used in the English language. One word is the word and, in which I now have what we might think of as a compound statement, in which we give that a special name because of the word and does anyone remember what that statement might be? None? This would be the conjunction, C-O-N-J-U-N-C-T-I-O-N, conjunction of the two given statements. Okay? By the way, in the statement that we have here, this conjunction statement, is this one true or false? We have to be able to decide that. And here we have certainly this part, 2 plus 3 equals 5, we know is true. And 17, however, 17 minus 2 is not equal to 15, we know is false. What's our conclusion about the entire statement here, this entire compound statement? It is false, okay? And in fact, let's write one down, 2 plus 3 equals 5. And, well, let's just say, 18 minus 2 is not equal to 15. And now what is our conclusion about this conjunction? It is true. So what then can we decide about when a conjunction is true? Here in this case we have two parts. Bill, what can you say?
Well, if both statements are true, then the whole thing.
If both statements are true, okay, let's say that right here. Both must be true in order to make the entire conjunction statement true, okay? And then, of course, we may also take a sentence, a statement, 2 plus 3 equals 5. Oh, let's start out again with this one that we have, 17 minus 2 is not equal to 15. And we can combine these two simple statements with some other words, probably lots of words, but another popular one that we could select is or, all right? And there's a fancy word that we use to describe this, Michael says, the disjunction, D-I-S-J-U-N-C-T-I-O-N, the disjunction of the two given statements. Now in this case, we know that this simple statement is true, and this simple statement is false. What's your conclusion about the entire statement here, Dick?
At least one of them.
At least one of them has to be true in order to make the entire sentence, the entire statement, what? True. Okay? And I think here we may use the phrase, what? At least one is true. Okay? At least one of them is true. Very good. Well, let's see now. Where can we go from here? Oh, let's then take this simple little statement again, 2 plus 3 is equal to 5. And if I call this a statement, what I'd like to do is to write the negation of that statement. All right, let me just put in the word there, negation of this statement. And what then would the negation of this statement be? 2 plus 3 equals 5. I now would like to say something about, what, Doug? And then simply to negate that would be to say that it is not equal to 5. And of course, I think you will agree that this symbol right here is one that you've seen before, and which we may say not equal to. Is that right? Okay? Is not equal to. Or perhaps let's then take the case of 17 minus 2 is not equal to 15 as our statement. What then would be the negation of this statement? Let me write in the word negation here. What would be the negation of this statement? And 17 minus 2 is not equal to 15 is the original statement. Tom said 17 minus 2 is equal to 15 would be its negation. Is that right? Okay. Well, from this idea of a negation, I think what we can do is to perhaps look at one or two other ideas. Again, let me start out with this simple 2 plus 3 is equal to 5, a simple statement. And let me use the word and let me now make up some other all such as 18 minus 2 is not equal to 15. Okay? Now, again, 2 plus 3 is 5, we know is true. 18 minus 2 is not equal to 15, we know is true, and therefore the conjunction statement is true. All right? So let me just call this our statement. All right? Let me introduce a symbol. Let's let the letter P refer to the statement 2 plus 3 is equal to 5, okay? By the letter P, I simply mean all of this. Instead of having to write this every time, let me just call it P, okay? And let's call it Q be the other statement here. 18 minus 2 is not equal to 15 be that statement, all right? So we could just as well write what? P and Q. And in this context, then, it refers to this, in which we may then, if P then were given some other name, if Q were given some other name, we then would could still talk about P and Q in that context. And in general, then, I think we may use the phrase P and Q, which P may be any statement, and Q may be any other statement. Well, what I'd like to do is to come back and look at that and try to take the negation of the original statement, which is right in here, okay? Now, how then may we negate this entire statement? That's the question. And as given, this one is true and this statement is true, and in order to be able to come up with a negation of that, we have to come up with something which is false. Is that right? So when then is this original statement going to be false? When we take its negation, and what then may we say about that? Does anyone have any idea? Doug?
Not P or not Q.
Not P or not Q. Well, let's perhaps come right back to here. I think then you're saying that 2 plus 3 is not equal to 5. We have to negate this one. Or, is that right? The word or now, we have to negate the other simple statement of 18 minus 2 then is equal to 15. Is that right? And then in general, if P and Q is our statement, the negation of P and Q would be, Doug, let's actually write that down. The negation of, let me put it in quotes, P and Q is what? And now you wanted to say
Not P or not Q.
not P or not Q. Notice the use of the word or in this context, okay? Or not Q. And let's then do a last example, which I think is going to illustrate 2 plus 3 is equal to 5, and it will illustrate the use of the word or, in which we would like to negate this idea. 18 minus 2 is not equal to 15 is our original statement, okay? And using the same symbolism, here we have P or Q. And now what we would like to do is to write the negation of this. And let's then now look at the original. Here we have this or this. All right, and it turns out that certainly this statement is true. So what we now would like to do is to write some statement which is then going to be false. And what then can we say about that, Bill?
Not P and not Q.
Not P and not Q, which in this case is 2 plus 3 is not equal to 5. And, now notice it changes to the use of the word and, 18 minus 2 is equal to 15 would be the negation. Is that right? So we can generalize that to say what? The negation of P or Q is, and what is that, Bill?
Not P and not Q.
Not P and not Q, okay? And I think then that this would be the negation of this given statement. Well, I don't think that there's much more that we need to do for today. I think this is a rather simple and easy lesson, and I think you're all smiling and saying, well, if this is all there is to it, why, there's no problem. And I think that that's the way in which it will proceed all year. I'm going to give you your homework assignment for next time, and I think that's